Hi, I'm Hongxian Chen from National Zhenjiang University, Taiwan. I'm going to show our work, TransPF, rendering unidirectional impact feedback with dynamic point of application of force around a controller. Impact force is common haptic feedback on VR controllers, such as hitting objects with weapons or rackets. Impact force applies to different points of application of force, PAF, and in various directions in different scenarios. For example, using weapons with different shapes, such as a sword and a pickaxe. Their shapes are different, causing different PF and force directions. The red dots represent the PF, and the red arrows represent the force directions. Furthermore, using a weapon in different ways, such as stabbing or slashing with a sword, also causes different PFs and force directions. Therefore, to achieve realistic VR experience, rendering dynamic PF and force direction is essential. Some works render dynamic force direction, while their PF is fixed. Others dynamically change the PF, but the force direction is limited. Therefore, rendering force feedback with dynamic PF and force direction still ways to explore. So, we propose a controller, TransPF, to render unidirectional impact feedback with dynamic PF. TransPF is composed of a controller, a semicircular track, a linear track, and an impactor. And for dynamic PF, the PF movement consists of three factors, including the azimuthal angle theta. The controller rotates the semicircular track on the theta plane for the azimuthal angle, and the inclination angle phi. The linear track moves along the semicircular track on the phi plane for the inclination angle, and offset. The impactor moves along the linear track, which is similar to the radial distance. And for dynamic force direction, two factors determine the impactor's direction, including the azimuthal angle theta r. Through the rotation of the linear track, impactor rotates on the theta plane for the azimuthal angle, and the inclination angle phi r. A servo motor rotates the impactor on the phi plane for the inclination angle. Therefore, by moving and rotating the tracks and the impactor, TransPF achieves dynamic PF and force direction. And we improve the impactor of our previous works. It lacks impact and impact vest. The impactor stores the power and generate impact by impressing and releasing the spring with a shorter power storing duration. And to understand the user's distinguishability in position and direction, and to observe whether the torque affects the distinguishability of the PF, we conducted a just noticeable difference study. Here are the results. Without torque means the impactor is parallel to the linear track, and the red arrow represents the force direction. With torque means the impactor is perpendicular to the linear track. Although there is no statistical significance, the results show that the distinguishability with torque is slightly better than without torque. And based on the results, we summarize and propose three guidelines for the future works. First, the design of virtual objects. To allow users to perceive the PF and force direction difference between virtual objects in a VR scene. The difference must be beyond the Jandy thresholds. And we follow this to design our weapons for the VR study. For example, the phi angle difference between the sword and pickaxe was 60 degrees, which was based on the result. And second, reducing the latency, since users cannot distinguish the difference less than the threshold, which means that always rendering authentic PF and false duration is unnecessary. Therefore, the device could actuate only if the difference is beyond the JNT thresholds to reduce the latency. Third, reducing the range. We found a phenomenon that users could not distinguish whether the impact stimuli are 5R greater than 0 degrees or 5R less than 0 degrees. Therefore, the device could render a smaller range for 5R and reduce the latency. And we conducted a VR study. Participants used 4 weapons, including a sword, a pickaxe, a hook, and a dagger, and a tennis racket in the VR scene, to attack monsters and hitbox to perceive impact feedback. And for the sword, there were 2 ways to use it: slashing and stabbing. For slashing, according to the position of the blade of the sword hitting monsters, the PF could be in 3 positions. And for stabbing, use the tip of the sword to hit monsters. And then use the pickaxe and the hook to attack monsters. And for the dagger, the tip is toward the ground. And for a racket, the racket might hit both in different directions. Therefore, the impactor direction was adjusted correspondingly. And the results are shown in the figure. 3 methods were compared: dynamic force direction D, dynamic PAF P, and trans-PAF T. Their differences are shown in the table. The results show that significant differences are between D and T in realism. In addition, we analyzed the realism of each weapon and the racket. Use a dotted line to indicate the same feedback. The results show that the feedback from T was more realistic than that from D and P in different situations. And we can see the results of P is better than D. Therefore, we suppose that PF has a stronger influence than the force direction on VR realism. And the current trans-PF prototype still has some limitations. First, latency. The average latency of changing PF and force direction usually happens in switching weapons. We can use some visual effects during switching, which can further reduce the delay issue in the future. And the power storing time will limit the consecutive impact scenarios. Second, weight sensation. Due to the torque, the impactor moving to different positions could increase the weight sensation. The lighter impactor design could solve this problem in the future. And the impact is generated by the impact particle hitting the bevel, and it is further delivered to the controller, which might lose some impact power in the delivery. The advanced design of the impact directly applied to the linear track could solve this problem in the future. And in conclusion, we propose a controller, trans-PAF, to render unidirectional impact feedback with dynamic PF all around the controller. And we conducted a JNT study to understand the distinguishability for PF with and without torque and force direction separately. And based on the result, we performed a VR study to verify that the feedback from trans-PF significantly enhance users' VR experience. Thank you for your attention. This time, we will also demonstrate our device. Welcome to experience.